How you doing, Peggy?
Me and you, baby.
I don't know about you. Okay, let's get started. We have an individual that I want to introduce to you first. He's been in an extension, the Texas A&M extension agent for 35 years. He oversees this building, this AgriLife. He oversees naturalists, and of course you see all these 4-H things, and he and us. There's 3 organizations that he oversees. Okay, so he's been around 35 years. And he's here to help any way he can. If you have any issues that you want to talk to him about in regards to the Texas A&M organization, hello. Heads up. He can answer your questions. Did everybody sign in? Did everybody turn their tests in? Okay, this individual, his name is Travis. Hey Travis, come on up here.
Travis.
Thank you for that fine. Welcome. My name is Travis Frankie. I'm the county extension agent. Do I need that?
Speak into?
You want me to sing?
No.
Okay. My name is Travis Frankie. I'm the county extension agent for agriculture here in Guadalupe County. We work for Texas A&M AgriLife Extension. We are a educational agency. Basically what we do is we conduct educational programs for farmers, ranchers, homeowners, and we are in charge of the 4-H program that a lot of you have probably heard about, which is our youth aspect of what we do. Okay, so I want to take this opportunity to welcome you guys here to the Master Gardener training. You have some guys here that do an excellent job putting these programs on. It is a very intense training, and you will find that out as you go through. I apologize for not being here last week, but I happened to be in Tahoe skiing down a little slopes and that kind of thing there. So, well, it depends on what kind of registration you want to pay. We possibly could. Basically, what I want to tell you today is a little bit about what we do, how extension works. We are joint with the county, Guadalupe County. We are very fortunate that our county judge and county commissioners are very, very supportive of our program. This building that you're in here was built in 1952, I believe. It did not look like this in 1952, I can tell you that. This room that you're in right now, where those first columns are right there, that was separate offices. As a matter of fact, the Farm Services Agency used to be in this area that we are right now. Okay, so they moved out. The building was getting a little run down. County judge commissioner said, okay, we need to redo that building. So about 8-9 years ago, they spent a little over $1 million, like $1.2 million redoing this building. We are very fortunate to have most of it. The only office that we do not have is up here in the corner, and that's where the game wardens are. Okay, Master Gardeners have a big office upstairs. Our Master Naturalists have an office up there, and then we have an few extra meeting rooms, that kind of thing. So if you run into your county commissioner or you run into the county judge, thank him for giving us what we have here. If it wasn't for them, we wouldn't have this facility here in order to do these types of trainings and programs and that kind of thing. Okay, Master Gardeners, a very good organization here. We're very fortunate that we have the leadership that we do have in order to keep these things going. I will tell you, when I moved back to Guadalupe County in 1999, see, I'm showing my age, that 35 years, the Master Gardeners were here. Gus Person started the Master Gardener program back in the late 80s, early 90s. The program was going. Gus retired. New agent came in. They were here for a year or so. that agent left, went somewhere else. This position stayed open for a couple of years. During that time, the Master Gardener program kind of went shh, because there wasn't any agent type support to it. Trainings weren't happening. The new training classes weren't happening. So when I moved back here in July of '99, I got with the then was the president of the Master Gardener program. He came to me and said, hey, we need to get this thing going again. So we did. So we've been doing that since July of 1999. When I got here, we had about 12 members that were left, and what are we now? We've been up to 150. We're about 130 something now, as far as the Master Gardeners are concerned. Okay. So what we're hoping that you do is when you go through this class, okay, yes, you're here to learn about gardening. You're here to learn about propagation. You're here to learn about all those things. Okay. What we want you to do is become certified, take an active role in the organization. Okay, and then maybe somewhere down the line, you'll be in maybe one of these positions that these guys are in to help lead these classes, to help educate others, okay? And to be an active part of the association where we can bring gardening stuff to the people of here in Guadalupe County, because that's what we're charged to do. Basically what we do, we bring research-based, unbiased ideas and proven results from Texas A&M University to the people in Guadalupe County. Okay, so people can call us, and we're not going to try to sell them anything. Okay, they're calling us for the information that we have. Okay, so how we disperse that is through things that the Master Gardeners do, like the Lunch and Learn programs, like the library programs that they do, different things like that. Our primary goal is education. Okay, so we want you to become a part of that, to become certified, maybe to go to some of these advanced classes where you can get even more certification on a specific topic where you can come back and teach that. Okay, so that's what I want you to do. Now, you may choose not to do that. You may come here just for the education, and that's fine. That's fine. It's your money. You spend it. You can do whatever you want to do. We want to encourage you to become certified and become an active part of the association that we have here. Okay? Any questions for me?
Who funds all this?
Who funds all this? Okay. The county provides office space, travel, support staff, and anything else that we need to run this office. Texas A&M AgriLife Extension takes care of our benefits, part of our salaries. They are our main bosses. Yes. Okay. Yeah. So it's either Texas A&M University or Texas A&M AgriLife Extension Service, and funding from the county as well.
So you follow their itinerary?
We follow A&M's itinerary. Yes. With support from the counties in which we work. We have agents in all 254 counties in the state of Texas. Okay. Now, not every county has one. Some of the counties out west where we only have 4,000 people, there may be a combined, those counties and that kind of thing. But we have representation in every county in the state of Texas. So. And then, you know how A&M works. A lot of that is state funded. Some of it is federal, not very much, just a small part. But majority of the money that we get for our budget is through the state legislature. Any other questions? Yes, ma'am.
What's your degree in?
I went to Tarleton State University.
Tarleton?
Tarleton in Stephenville,
Oh, okay.
The better part of the A&M system. And I got my master's in ag education from Texas State, or Southwest Texas State University at the time that I got mine. Okay, but my degree from Tarleton was general agriculture at that time. It's the same thing now as ag services and development. That was a long time ago.
That was a party school.
Well, we did have a good time. But yeah, I will tell you, my whole deal with Tarleton was you know, I was going to go there 2 years and then transfer to A&M because I came from a real small town south of here called Wasatch, Texas. I don't know if anybody of y'all ever been through there, close between Goliad and Yorktown. So, you know, I grew up in a small school, that kind of thing. So I was going to go to a smaller school, you know, just to get my feet wet. Well, I liked it so much I stayed there. And Southwest Texas was just close to me at the time to get my master's. We used to be required to get our master's. We're not anymore. Because that was putting some hiatus on recruiting and that kind of thing. So at that time, we had to get our master's. So that is my education. Anything else for me? Okay, again, my office is right down the hall. If y'all ever have any questions or need anything from me, that's where you'll find me. Give me a call, come by and see me, leave me a note. If I'm not there, I'll promise you I will get back to you. Okay? Again, welcome. Glad you're here. Hope you enjoy the training, and I hope you become certified and become an active member. I look forward to working with each of you. Thank you.
Thank you. Hey, David, as a matter of fact, we're going to be scheduling a class, Master Gardener class, in Colorado ski resort next year. Next year.
They have a one-legged ski, I'm in it.
I don't need that. Yeah, they have those bikes. Yeah, I know. Very good.
Stick here and keep the fork down.
You don't like that? I don't like the snow. All right, you've got an announcement? Couple of announcements? He's got the announcement. Okay.
Hey, so thank you, Travis, very much. He's a very likable individual.
You want the next one?
He likes to drink hot coffee, so you know, he's a very helpful gentleman. A couple things real quick as we move forward. You're the biggest class we've ever had since Paul, April, and I have been here, so that's a wonderful thing. But I wanted to go over some things real quickly before our next presenter to make things a little bit maybe more organized. Today, the ladies' restroom right here on the ground floor, I think there's 2 stalls in there. One stall is not working. So ladies, that we have a mass exodus, the ladies going to be thinking about there is ladies' restrooms upstairs. You can go up the staircase or you can use the small elevator over here, okay? So you're welcome to do that. When you first walk in this door in the future, please sign in, initial in that we know you're here, we take attendance because that's very important for us. Drop off any speaker evaluations that you did not turn in the week before or any backup tests or anything in that document box over there. That way these volunteers over here can go ahead and start trying to grade those, and with being a larger class it takes longer to grade them, and we try to always hand out the tests back before you leave at the end of the day. Make sure you turn off your cell phones, April.
It's off.
Okay.
Sorry.
And
It was our president, by the way.
speaker evaluations also need to be turned in, okay? When you do typically come in, sign in, then you go over to this back table, pick up your name tag, a wooden table tent holder, and anything else that we have. We usually have the speaker's presentations printed out with their speaker evaluation on top of those. So, because we always like to know what you all feel. We always like to have your input as we move forward. So please do that, and then make sure you turn them in at the end of the day. Today we have some extra bags and things that are made available from Kay Woolman out at the Big Red Barn, which is one of the demo gardens, one of the education centers here in Seguin. Please take one. Hopefully everybody will take one. That way we have, make sure everybody can have at least one. Okay? Also, yes, April put these out for everybody, not for something else to carry, but we also have a 3-hole binder. So a lot of people have asked that they had a 3-hole binder, 3-hole punch. You can punch your presentations that are handed out at the beginning of the class, and you can put those in there for future reference when you take them home and put them in your bookcase. Try to keep the top down a little bit. There's 4 clipboards back over there where Travis is standing. One is about helping with snacks and setups. One is helping to set up the class and closing the class down, making it presentable for the next group of folks that use this room. This room is really used a lot. There's also a third clipboard about putting together a newsletter of what we cover and what you see as positives and so forth. And then that goes into our quarterly or our monthly newsletter. And then the last one is giving a small briefing to our membership meetings that we have once a month. So I just wanted to get that to you. You want to go?
One quick thing, those that brought a snack today, good job, thank y'all. That was some good stuff back there, thank you. Okay,
But we appreciate you being here, and I'm going to sit down and shut my mouth.
and turn your phone off.
My phone's been on.
Okay, we're going to get started with our first speaker.
Are the meetings here in this building?
Which meeting?
The ones you volunteer, yeah.
Yes.
They're down here. Oh, yes.
The lunch and learns and the one
Paul,
That lunch and learn, is that considered a volunteer hour?
continuing education,
Continuous education, which you really don't need right now.
Okay.
But
unless you want to.
there is some other stuff going on besides that lunch and learn meeting.
Right.
That's a 1 hour thing, but the lunch and learn needs, that we have kind of a social time and they cover some things that we want. You can get an hour on that. Okay. Lunch and learn is open to the public.
Yes.
Yes. So is the monthly meeting. Okay. So anyway, our next speaker, he's a doctor of computers.
Did you say Dodger?
Doctor.
I'm the dodger of computers.
I know how to turn it on.
He is the Guadalupe County Master Gardener's Membership Director. He was in class 39, your own class. You know, Travis was talking about, you guys can get involved with our organization. He did. And now he's on the board of directors, or as a director for the membership. Okay? So those are things that you can do. Now he's going to talk to you today about our VMS system. How to log hours in for those of you that are getting hours because you have your background check back. And by the way, be sure you're writing your hours down somewhere until you're able to put them in so you don't forget them. Okay? If we said to forget them and say, oh, what did I do? When did I do that? So be sure you write them down when you get them and then put them in the system. So anyway, our speaker is Dr. George. So this is what's from Dr. George.
Get rid of that one.
Yeah. Doctor of Computer Science, I hate computers. How y'all doing? Really good setup. Good to see you all. Welcome. Not gonna lie to you, I have the honor of doing probably the most not good section, but we'll get through it. I'm up. Oh, I need my little microphone. Sorry. And the clicker. All right, yep, that's me, just what we're doing. I have tried to make this as fun as possible, but it's really kind of like making a tax law lecture fun. So we'll get through it. This is what we're going to go over. There we go. The mission statement. Travis kind of hinted on this a little bit, but our goal is to educate Guadalupe County in the best way to grow stuff possible. Whether you decide to do that, decide not to do that, it's up to you. My wife took the class and she's my helper at home, and that's what she wants to do, and that's totally fine. But as far as membership goes, this is kind of important because you'll see the top one is the education, the protect and conserve natural resources that we do by just giving good information. But the bottom one, develop a strong master gardener organization, that's kind of where I come in. My goal is to get as many of you in and keep as many of you as long as possible. And I will pretty much do almost anything to do that, but within reason. What's that?
You waste cars.
No. I do have a son here in Seguin, and we might be able to set that up. Okay, we'll get to this is a little delayed. Oh, I guess I gotta go this way. There we go. All right. Excuse me. It is January, cedar's still going. I'm a little cedary. These are different type of memberships we have. Okay, trainee, pretty much you're enrolled in the class, you finish your background check. You're usually a trainee until May. Then once you're done the class and get your certificate, you're either going to go to intern, which means you still have to get your hours, or, and this should be your goal, get your hours this ends in May, so slowly get your hours. It's doable. I got my hours alongside graduation, and I didn't really have to work that hard. It seems like a lot of hours, but it goes by pretty quickly. So you're going to be an intern or a Master Gardener certified. That's where all the rules kick in. We have an honorary member, which is someone who's not a Master Gardener, but they do a lot for us. For instance, I'm going to put him on the spot. Frank, he was our one honorary member. He does all the website stuff. He helps out all the time, so he had an honorary membership. And now I have to change my roster because he's going to be an intern, and we don't have an honorary member. Emeritus A, I'm not sure what the A is for. That's a lifelong member. I think we have 2 right now. It's like a excellent service, kind of at your end of your service, and you've done a lot of stuff. The membership will vote you in on that one. There is also a leave of absence status, and this is very important because we're going to get into all the requirements and all the hours and all this stuff. So you get certified in May, October. You guys are going to be good this year. So next October, you're going to start seeing my emails. Hey, you have your hours. Hey, you guys going to get your hours. If we all realize life happens, if you can't do it and you want to take a leave of absence, they're usually 1 year long. You're not some life incident, something, whatever. I'm going to push you to take a leave of absence. We'll get it certified up through Travis, and then you're kind of off the hook for the year for your hours and stuff. I do believe you still have to pay the dues. But what this does, and you can re-up your leave of absence twice. What this does, if you, the year after, say, hey, everything's good, I want to come back, all I have to do in VMS is change your status from leave of absence to certified. If you go longer than 2 years, you have to redo, you have to do 6 classes. You have to, there's a little more work you have to do. We can waive the leave of absence, I think, up to about 3 years on the board. But yeah, if something, just keep it in the back of your mind. If something happens, and I will let you know right away, you say, hey, Bjorn, who knows? I don't want to say bad things or wish bad things happen, but they do. I'm going to say, hey, why don't you take a leave you're not going to get your hours, why don't you put in for a leave of absence? And that way you're kind of covered and you can just come back whenever you want. And then the second one, the last one's retired, pretty much after 10 years. If you don't want to do it, there's another one. If you're under 10 years, you can just say, hey, I'm moving, okay? Under 10 years, you just get released. If you're over 10 years, you get retired. You can still do events. You would have to keep a background check up if you wanted to go do the volunteer events. Yeah.
I believe that if you lose your cert and you've been certified, that your retraining is basically free. It's not at what cost.
Yeah. The requirement, if you lose your cert and you need to come back, you have to audit 6 classes. So not the whole day, just like you guys sitting in here with me, that would be 1 class. And there's no cost to it. You just come in, sign the roster, audit your classes. But yeah, retired, you get, if you want to keep your background check up as you're retired, then you can do stuff, but you really don't have all the requirements that we're going to have. All right, here is volunteer hours. For you guys to certify 50 hours, and you have 1 year to do it. Like I said, it's not It's not that much. It builds up pretty quickly. I didn't work very hard at it, and I was able to get them done in the, sorry, I forget there's people over here I don't want to talk. I was able to do it by May, and you just go to one of the gardens, and it's easy. From then on, and this has just changed this year, and so we're also having to educate the certified people. From then on, you're 20 volunteer hours annually and 10 continuing education hours annually. And that is your minimum requirement to keep your certification each year. Time passes quickly, start early, and your goal should be to certify, if you want to certify, try and certify at graduation, because then you're free the rest of the year, and I'm not going to bug you. Ma'am?
When you say annually, does that like reset every January?
Every January, you go back to 0. Yeah, and then I don't bug you until about October. I'll send, if it's August and you're kind of at 0, I'll give you a little poke and say, hey, you're kind of at 0, what are your plans? Around October, because around October we start collecting dues. And we're not allowed to collect dues unless you have your hours. It's in the manual. So around October, I'll start. It'll be a little heavier prod, but it'll still be a prod. Okay, the rules.
Travis, do we have to have continuing education credits? Like, do we have to still take class? Do we have to take like a refresher class?
No, I'll go through what will count in that. Okay, the rules for these out. Volunteer hours, any activity that promotes GCM, our mission statement. For instance, my grandson's school has a little garden, right? I go there every once in a while and I show them how to do stuff. Okay, I can count those hours. The difference is I'm giving a class. Ongoing maintenance of approved projects. I'm going to get a list, and they're going to give you a list. It's in VMS, but of all the approved projects you work on, the Big Red Barn, all the demonstration gardens. You can go there. These are the only ones on the approved list that you can just go and do maintenance and get hours. Like, I can't go to my grandson's school and maintenance it for 2 hours and then collect those hours. I've got to be teaching or demonstrating or something like that. Here is, okay, membership meetings. You get credit for membership meetings, okay? As an intern, you are only allowed to use 6 hours for membership meeting. That includes driving time. So for instance, if it takes you 30 minutes to drive to, it's an hour meeting, it takes you 30 minutes, that's 2 hours. You can only use that 3 times for your membership meetings. You have to, we want you to get out into some of the gardens and see what's going on. But you can use those. You cannot use hours for any profit organization. So if you, I don't know any, but if you go help Home Depot, yeah, say you volunteer the water the plants at Home Depot, you can't take that. Any presentations or teachings, like I said, and then drive time counts, okay? I'm gonna show you. It takes me 42 minutes to drive here. I get that time, okay? Sorry? Oh. Okay. To volunteer at the projects. I told you this was going to be fun, right? It's like to volunteer at the projects, you have to have your background check completed. You have to have the volunteer agreement form signed, which I've got 35 of them, so you guys are all good there. And then you got to have motivation and can-do attitude. The gardens are fun. I liked going to the gardens. Oh, there we go. Okay, continuing education, to get your point. We provide you all the continuing education that you'll need to get your 10 hours. The lunch and learns, We do them in Seguin Library. We do them in Schertz Library, and they do some in here. And I've just got them all listed on VMS this morning, so they're all on there. Monthly membership meeting speakers. Okay, so I told you there's a limit on volunteer hours for the monthly membership meetings. Each membership meeting has a guest speaker, talks about a certain subject. Those, there's no limit. So if you do the math, we have 10 membership meetings a year. Each one has an hour-long speaker. So if you come to every membership meeting for the year, you get your 10 CE hours. If you're in a pinch, that's the way to do it. I recommend going out to the lunch and learns and then the other stuff because they're really good. Bill Nodine does them. He does a bang-up job on them. Online AgriLife extension training. We'll get to the AgriLife Learn Center because I know that's probably a problem for everyone, or for some people. They have other classes in there, and they have other gardening classes in there besides that volunteer thing that we all have to do. You could do those. We have classes online every time. We record everything. In fact, we just had a kind of marathon session in December to get CE hours. And, hey, go watch this and go watch this, and it'll give you the link, and you go watch the video, and you can take hours for your CEs. Travis hit on this a little bit, advanced trainings. There's vegetables and propagation. And, you can take those, you can advance. There's requirements for those, and that's Bill Nodine. I don't deal with it other than the fact, but you can log all those hours. And then, of course, drive time counts going to your trainings as well. So if you go to a lunch and learn, 15 minutes there, 15 minutes back, that's half an hour on top of whatever the lunch and learn time is. So you can, there's really not a lot of restrictions on the continuing education. Like I said, if you just come to the membership meeting, that sets you solid for the year. You guys will have plenty enough training this year. You don't have to worry about this until next year.
January.
Yeah, you start on January. I reset all your clocks to 0. And then it's a race to see who gets there. Okay. All right. A show of hands, who has been able to log into VMS? Yeah. So, in general, just log in. Okay. Who got an email last night from me? Okay. Okay. The VMS system, it's what we have. It's good in some ways. It's kind of difficult in some ways. Luckily, as you go through and you're certified, you really only have to deal with one thing, which is logging hours. Okay. Getting in, and this is going to be more important when we get to the background check. Opening some of these accounts, I have a doctor in computer science, and getting my background thing started befuddled me. So opening these accounts and getting them all started is not the easiest. It's not very straightforward. It's kind of cumbersome and stuff. Once you get your account set up and everything, it's a lot easier. You just open it up, log in, put your hours in. That's all. It gets a lot easier. What we're going to do, I'll get to that. So this is where you log your hours, quarter-hour increments, and round up. So 42 minutes for me to drive here, 45.75. Fill out your profile. There's information in there. Especially in your profile, you're going to see there's a section of your interests, and you can just click all the boxes. And we're going to go through you're going to click all the boxes. Really fill it out and let us know what you're interested in, because that kind of drives the lunch and learn classes and all the education and stuff that we do outside. Be sure to outreach data. Every month, They collect up our VMS information and they send it to the state. And in that information is all the people in the county that we've reached. Like if we have a lunch and learn, there's 2 rosters. So there's a roster for the members and then guests sign in, and those guests are outreach. And there's a place to put that in there. For you guys, don't worry about it right now. Once you get familiar with going in, doing it. If you were at the Big Red Barn and you talk to someone for 30 minutes on how the peas are doing or whatever, just, hey, I talked to one person. It gets a little detailed, like, was it a man, a woman, a child? You can just put a number in. Help each other. I'm here to help you. In fact, we're gonna set some up when we're done. But yeah, if you're in and you got in, we've got the computer over there. Frank's a whiz. Frank's better at logging into the background check thing than I did. I've done it once, and he's really good. So we've got that set up over there if you want to get your account for your background check. The good thing is, and that's our next background check. This just, I think it was starting last year, was that so just starting last year, they put that video requirement in. Luckily, you only have to do this once every 3 years. It's about a 3-hour video, and I was in the Navy, so I know how to turn videos on and then not pay attention to them. Apparently, they know that because they require you to do clicks and stuff, so you got to kind of be engaged. Once you do the videos, you get a link over to the actual background check, and that's just, you just fill out some information and you send that in. And then all the background checks will get approved. Once they come back, they'll get approved by the CEA. It is not, yeah, ma'am.
Does it take a long time?
The background check, a day or 2. No, a day or 2 to get it back.
Okay, so I may have done something wrong.
Okay.
Because I did it before we started all this. I don't think I did. I don't think I've heard anything.
Okay.
But that's just personal.
Yeah.
Talk later.
And on kind of like her, but when I went back in, they said to share with Texas Governor, but I didn't have to, so it looked like there was a little check right there that says it's been seen.
Yeah.
So that may have been happening first.
Yeah, we'll check. We have access to the EVS system, which is where your background checks aren't logged in VMS. They're this, of course, a whole nother system that's not even as nice as VMS. So luckily you guys don't have to do it. We have access and we can see who's got it and everything. And I'll track that so that in 3 years you're going to get an email. Hey, your background check's due. Hopefully you still have your username and password. Write that down and stick it on the bottom of your desk or something. Also help your client. This is your first service task. If you are in and got through it successfully, help out. Before we get into some demonstrations, I'm available to help. As always, you have my email. Email's the best way to get me. If my wife's not with me, I don't have my phone. Or if my wife is with me, I don't have my phone. If she's not with me, I will have my phone, but like right now my phone's out in my truck. Yeah. And I work odd hours. But yeah, email's the best. gardendoctor@protonmail.com. I will help you. It's hard to do it remotely. So if you can't get in and I can't see your computer, we'd have to meet somewhere, which is, and like I said, if you're in and you breeze through it, help your classmates. Enjoy your time in this. Like I said, I took this class last year. It's drinking from the fire hose. I'm not gonna lie. It's great information. So my spring garden last year before taking this class was my fall garden after taking this class. I filled a 42 cubic foot freezer in produce. So the information is really good. So yeah, enjoy the class. More importantly, enjoy the gardens. This garden over here is beautiful. The Big Red Barn. I haven't been to. I live in New Braunfels, so I haven't been out to some of the other gardens, but they're good as well. Yeah, get out to the gardens. So now we're going to do. Well, first, are there any questions just on the general stuff?
What's your email address?
It was on that last slide, I'll put it back.
Yeah, we'll put it back. Yeah, it's Garden Doctor at proton, P-R-O-T-O-N, mail.com.
Proton.
Yeah, it's a Switzerland-based, encrypted, non-government subpoena. Yeah, I'm a cyber geek, yeah.
We need to talk.
Mail,
We need to talk.
yeah,
M-A-L-E?
yes, .com. Mail, oh yeah, M-A-I-L? Yeah, Proton Mail.
I thought you were going to mail yourself to Proton or something.
No. Okay, I think I can escape out of this. So let's go.
Not yet, you're not.
Yeah, again.
There it is.
Okay, do you have, what do you guys use for internet? Is this internet? Okay, so I'm going into the AgriLife Learn site right now. This is.
You got a P.M. Johnson.
All right. Logged in. So this is the basic website. And then I'm going to also Texas VMS. Okay, how many people have seen this screen? Okay, so this is the Texas VMS system. So this is the there's the VMS and then the background check. That background check you touch once every 3 years and then forget about it, okay? Once you get your background check done and everything, write your username and password somewhere, put it somewhere safe, and then never have to go to that system. Although I will say, they do have good stuff on there. Like I keep bees as well, and I'm doing their master bee program in there. They have other kind of stuff you could be interested in. Yes, ma'am.
What is the website up there? I can't see.
It's https://VMS.texasmg.org.
We'll send it to you.
Yeah. When we get out of here, I'm going to send everyone a bulk email. We'll have all the links and everything into it. Okay. So I think I'm just Bjorn in here.
But we can't go into this until we finish our background, right?
No, when I made your account, you should have gotten an email. You can log in now. If you don't, we'll sort any issues out. So wrote my password down here.
Did you give them a blank password to give them the first time?
No, but it gets sent out. See, April, now you made me. All right. Okay, so this is your home screen. Like I said, I woke up real early so that I can look like I did a lot of work, and the news page here. This is your class information, but here's the flyer for the next membership meeting, and then below that are all of the lunch and learns and library talks for, I think Bill has them up to through June. And then for some of them, you're gonna see, like the Shirts library likes you to register. So I've got that's the register link below there. You can click on that. It's like an event register and you can register. But I try and keep that up as best as possible with stuff for you guys, so you can go, oh, hey, I need another hour, or I need a CE hour, and you can go in there and find the stuff. You're not going to have this one because that's everybody, but if you go down, at some point you're going to have where that first table was. On mine is a little different, so you're going to have your table, and it's going to list your hours that you're putting in there. So you can keep track of that. So right now I have 40 hours and 156 miles, which I was told that this job is only going to be like an hour or two a month, and we need to have worse. The main thing you're going to do on here is log hours. Fortunately, I'll just use this thing. You go into your information. Like, you're not going to have administration or activity reports. I think you do have a link to the calendar and yeah, stuff like that. But this should be the same for you. Your information, add new hours. Okay? Straightforward. Now, we are in Guadalupe County. That should be your name. Project. This is the important one. And like I said, we're going to get you a list of the projects. But all the different garden projects are in here, plant sales are in here. We just did one for the grow team. Everything that you're allowed to collect hours for are listed in here. So this one, I am doing Master Gardener Organization support. Okay. You can change the date if you need to. So it took me 42 minutes to drive here, and I'm doing so always round up, right? So that's 45 minutes, and this is I think I had a 45-minute time slot, which, oh my goodness, 9:50, right? Sorry. So that's an hour and a half volunteer hours for me. So I could put that in 1.5. So you should only ever have 0.25, 0.5, 0.75, or 0.0. All right. I don't get E hours for this because I'm teaching it, but it is 38 miles round trip for me, to and from. I put the description, taught membership class at class 40. You don't have to write paragraphs in here because this is an honor system. I don't check it. Just be kind of descriptive, what you did. There are some things, like we're running the mentorship program that I'm gonna have to check, making sure the mentorship program is not doing maintenance, but other stuff. But yeah, real brief. Hey, I drove, supported the plant sale, and that's it. Or, I went to the Big Ring barn and picked onions or stuff like that. For just a little sentence, mostly because you have to fill the box out because it won't let you go further, but just a little brief description of what you did. Like for this, that's all it takes. Okay, this is the other section. Yeah.
And this is approved
to administration?
Yeah, yeah. I have yet to figure out how to track, because don't worry about this right now. A lot of this, the leadership they do when they get the rosters from Lunch and Learns and stuff. But quite honestly, yeah, this is kind of like broken down severely.
Kind of like a racial profile.
Yeah, but the county gets their state and federal money for outreach. And so they really like these numbers because, like, hey, you know, we're reaching all these communities, whatever. I don't think I've ever filled this out yet. One, so.
It should say indigenous instead of Indian.
Yeah. Also, the VMS is programmed by some graduate students up at Texas A&M, and I've tried to get them to change stuff. They don't. Yeah, right. So that's as easy as it is. And we're going to go in, add it, done. Now, and this is one of the things I tried to get them to change, but they won't. You can't put another one in, all right? If you want to do another one, you have to close it out. You would think you could do add new. No, you have to close it out and then start over again for all of them. Like I said, it's not the perfect system, it's what we got. But this, once you put 2 or 3 in, and that's really all you have to do in there, just your hours when you do it. So you can, if like, I have a doctorate in computer science, my wife can barely check email, God love her. And I don't like being on the computer all that much anyway. If you want to, you can minimize your interface with this as much as possible. Make sure you get your 20 hours and your 10 CEs. Do as much as you want. We're going to go into the background check. Most importantly with the background check, and when I went through the class, we did a little bit. I think I might have improved it a little bit. They are going to put a very detailed PowerPoint on your student page that goes step by step how to get in. And I was going to do it up here. You guys would have hated me. Yeah, no, I know I got to wrap up. I'm 5 minutes late. They would hate it. We're going to drop that on your page. Try your homework. Get into VMS. I'm going to be here for the rest of the day. If you haven't gotten an email for your VMS and stuff, come see me and we will make sure you have a username and password at least. The background check, go through the PowerPoint. If you can log in over here and get your account made, best. I am going to come back Tuesday next week, and if you haven't been able to log in or you're having a sticking time or having something, I will be here all day next week. We do it on break, we do it on lunchtime. I'll even stay afterwards, and we will get you completely set up in VMS and the background check. Yes.
Can you have a list of all of us who've already done our background check?
April has that.
April has
Yeah, ma'am.
So is there an amount of time that you have to enter the hours from the date it occurred with this system?
No, I recommend, it's good to do it relatively soon, sure. But you can backlog. Okay. Yeah, the date in there, you can like go back and change the date. It's just, you might forget and you lose hours.
Can you add multiple?
No.
Multiple things, like
there's no
6 hours, and you can then in a little remark section, you can put 3 hours at the Red Barn,
no.
3 hours.
It's all got to be, yeah.
Must have been a grad student on Red Bull doing it.
Yeah. I mean, I can't, I have full administrator access. I can't even do multiples. It's got one line. You can do volunteer hours and CE hours in the same block. but it's got to be on that one project. You only one at a time, then you got to close it out and start it over. So I apologize, like I wrote it, but it is what it is. So that's your homework. Try and get into VMS. Try and at least get to where you can see the video course on your background check. If you can't, like I said, I will be back here Tuesday, and by the end of the day Tuesday, everyone will be started with their video course. The last questions? Yeah.
You say that we're going to have enough continuing education hours of this class. Do we log that in, or does somebody log that in for us?
I don't think they have to. No, you don't have to log that in. You just get it. Yeah. Like I said, you guys are good until January, pretty much on VMS, except your volunteer hours, right? You do have to log your 50 volunteer hours, but you have a year to do that. So if you don't do it by May, you have until next May to get those done. After a couple times in, it's like I don't even think about it now. It's pretty straightforward. Anything else?
I know a lot of you are real anxious to get out and start volunteering. The page I gave you last week has got all the list of the gardens, and it also has in there when that person's going to be there for volunteer days. Until you're certified Master Gardener, you have to work with a Master Gardener. So you cannot volunteer at these gardens unless the POC, or the person of contact, is at the garden.
Or your mentor.
Yeah, or mentor. It's always a good idea to give them a call, but if your mentor's with you, you don't have to worry about it.
Yeah.
So if you're working in plant sales, you have to hang with a master gardener?
Yeah.
Well, you're there with a Master Gardener.
Gotcha.
Yeah.
You're right next to it.
Yeah.
I just wanted to make sure I'm not tied to their head.
Yeah.
If I do, I have to wear deodorant or something.
Okay, well, I'll bring some extra programs.
Yes, ma'am.
I was just saying, if it says Friday, does that mean Friday morning most likely?
Most likely, yes. I get about all the gardens working.
Yeah, like I got my 50 hours Friday at the Big Red Barn, 7 o'clock, 8 o'clock, and I just went until I got 50 hours. But that's all I have. If no more questions, like I said, just try, give it a college try, and then next Tuesday I will personally handle all the ones you bring. If you have a laptop or anything that you're going to use, bring that, because I will set up bookmarks for you so you can just click straight to the sites and stuff. Ma'am?
We have one with a laptop here today. You can go ahead and come to her right here.
Okay. Yeah.
iPad friendly or tablet friendly?
Yeah, it's a website.
Okay.
Okay, that's all I got. Thank you for being here. Thanks.
So our next presenter is here, but I think, Paul, you want to take a 5-minute break?
About a 10-minute break.
How do you guys know?
Our next presenter is Dr. Kevin Eddy. This gentleman right here. He's at Texas Lutheran University, the fine university here in Seguin. I say it's fine because my daughter went there, okay? Wonderful, not small university. But Kevin here is an assistant professor in biology. He started off from, has anybody heard of Purdue? Purdue University? Yeah. So that's where he got his landscape architecture BS at Purdue. From there he went on into University of Texas SA, San Antonio, and received his master's in environmental science, and then also his PhD from UTSA in environmental science and engineering. So the gentleman is very knowledgeable of what he's going to be talking about. And one of his areas of specialization that has always intrigued me, especially with all we hear about in newspapers and television and everything, is the changes in climate, changes and how it's affecting everything. Okay, everybody blames all the changes of climate and everything, what's happening in their backyard. But one of his areas of specialization is climate change and how it affects on plant competition. Correct?
That's right.
So this is Dr. Kevin Eddy. He's going to be speaking for a while. Please give him your utmost attention. He's got some good stuff, and thank you for coming.
Thank you. So thank you for having me. I did this last year, and I had a great time. So this is my second year at TLU, so hopefully the start of something long and good. How does this work? I don't know. Okay. Oh, really? Okay, never mind. So yeah, my degree, it's got engineering in there, but I didn't engineer anything. It's a weird combo. They stuck. I had calculus as an undergrad, but yeah, it's a weird degree program over there. Weird combo. Anyway, happy to be here. So just a quick overview of plant development and growth. I'm going to talk a little bit about diversity, and then move on to the morphology, why things are shaped the way they are, how they reproduce, and then kind of look at the life processes. How's my volume in the back? Okay? Great. So plants make up roughly a quarter of life on Earth. As you can see from the graph, insects are the biggies. There's about 1 million, those are approximate numbers, about 1 million species of insects that have been identified. I threw these old numbers from 1996 in there too, because you can see how much has changed. As science progresses and more people observe things, we find more species. We realize some plants and animals that we used to think are the same species are really different. And so you can really see how those numbers grow. When we talk about these species, we have a variety of ways of describing them. So everybody really is familiar to some degree with what we'd call a common name. Like Texas mountain laurel, that's a common name. And we can classify them like they're beneficial or harmful, or they're woody or herbaceous, palm or not palm. So those are kind of artificial schemes. But to keep things straight, we like to use what they call binomial nomenclature. And that just means that the scientific name has two parts. So I mentioned mountain laurel, and this is I love using this example. So the one on the left, that's Kalmia latifolia. That's also called mountain laurel, but it doesn't grow around here. We have this one. Right, that's our mountain laurel. It's funny because sometimes I give this lab to some of my students, and they go out and they measure mountain laurel leaves, and they do all this work, and they use that one, our mountain laurel. And then they go away from lab, and at the last minute, they write up their lab report, and they Google mountain laurel to figure out, because they don't remember the scientific name. They didn't write it down. And then they Google mountain laurel, and what they get is Kalmia latifolia. And so it's a dead giveaway. I'm like, okay, you did this at like 12 p.m. last night, and this is the result, or 12 a.m. So anyway, the common names, what you call something here is not necessarily what they call the same plant in like New Hampshire. So the scientific names, though, never change.
Well, we always called it a grape Kool-Aid tree.
Yeah, right. The flowers famously smell a little bit like grape Kool-Aid. So here's the whole rundown of our plant kingdom. So plant is all Latin names, plante. I don't know, most of the time we spend most of our time down here, maybe with family. Poaceae is all the grasses. And then the wheat has that species name, Triticum aestivum. That's a funny one because that's the only one that, the two parts together, they have to stay together. You could talk about Triticum, and that could be just the genus. But when you do the species, it's Triticum aestivum. Some of our, so plants all have some traits in common. There's a lot of diversity in plants, but they all possess chlorophyll A and B. There are other chlorophyll molecules around. There's like 4, but the photosynthetic parts of the plants have A and B in them. They all store food as starch, which is good for us because baked potatoes are tasty, and that's mostly starch. So you can see the starch molecule there. They're really long, and they do look a lot like the cellulose molecule, but the difference is in how the molecules are, the units are joined together. And that gives them different properties. So you can see that long cellulose molecule, you could liken it to a piece of thread, right? In fact, cotton thread would be made up of smaller and smaller units of that, as you can see there. You know how you like unravel a piece of string or rope? It's the same. The cellulose in the plant's cell walls is all made up of just microscopic versions of that string. The smallest you could go would be that molecule. So all plants have cellulose on their cell walls. All of them have a waxy cuticle that keeps water in and water out, so the plant can control its environment. And then that last one, distinct alternation of generations, which I always, this is a part of botany where I always sort of like feel like the explanation in the graph is more confusing than the concept. So y'all know, I'm sure, we have a plant, the flower, if it's a male flower, it produces pollen, and then the pollen goes and pollinates a female flower and then develops into a seed. That's all that's showing there. Is that pollen and the egg in the female part of the flower, though that is that bottom part of that where it says spore. And we don't really see that in the flowering plants. We don't really pay attention to pollen too much, but that's that alternation of generation. So we actually consider the pollen and the egg to be a different generation of the plant. They're just sort of self-contained, particularly in the egg's case. Okay, so plant kingdom, I mentioned there's about 390,000 species. And these are the big groups that we look at: mosses, ferns, the gymnosperms like pines and so on, ash juniper, and of course the angiosperms, which are the biggest. Most plants, like if we cast our eyes out there, most of what we're seeing are going to be angiosperms. That's the largest group. The mosses, those are about 12,000 species. They don't have any vascular system, so no xylem or phloem, and as a result, they have to stay really small because any nutrients or water or CO2 that the plant cell needs has to just diffuse in from outside directly. So as a result, they're small. As it says there, they do have a waxy cuticle on the outside, which allows them to be in some really rather dry areas, but their reproduction that always involves water. Those these little guys here are going to produce spores, and for the spore to get to the female part of the flowers requires water. So that's why you find them near streams and wet areas all the time. And even if they're dry, they can live in drier areas, but they won't reproduce until it gets wet or moist. So mosses are really sort of the first ones to make their way out of water into land, and they could do that because of the waxy cuticle. The next really great advantage was having a vascular system. So that's the xylem and the phloem. So now with a vascular system, the plants that have that, they can be much bigger because they've got xylem to bring water up from the roots, to distribute it to the areas of the plants. The phloem will distribute it around the plants. And so they could get really big now. In fact, ferns are the first ones to have this kind of system. They didn't have seeds yet, but they have a vascular system. And so, you know, millions of years ago, ferns were the dominant plant life around. They were like the cutting edge of plants. And they would be fern trees, like 60 feet tall. And it's all that material that when it died and got compressed over millions of years, turned into coal. So that's, they call that the Carboniferous age. So they could be really big. Nowadays, you know, maybe bracken fern is the biggest that we see around, you know, casually. Nice things, I mean, you can, those on the right, those violin neck things, call them fiddleheads. Those, on some species, can be eaten. Like saute them up, and apparently they're tasty. You don't want to get them when they're too old, because then they start to get a little woody, like, you know, when asparagus gets old, it's like tough. They also can be in pretty dry areas. This is maidenhair. I think it's maidenhair fern. I don't think that's maidenhair fern. Doesn't look like maidenhair at all, does it? They better take my degree back. It is a fern, though. That I'm confident of. And this one, this grows in drier areas. But again, moisture is needed for this reproduction because they still don't have a seed yet. The great innovation to make it a big success on land is having a seed. Because a seed allows that reproduction to be kind of separate from water. The gymnosperms there, that includes the conifers. Ginkgo is actually a gymnosperm. The name means naked seed. And these are the first ones to have seeds. And of course, you know, evolution's funny, you know, we don't have a clear picture on it, but you know, the ferns started to evolve this direction. So there's some really early plants that you would look at and say that's a fern, but it has a seed, so anyway. But we don't have to worry about that, that's in the past. What we have is now. So some really nice innovations here. Gymnosperms, they really thrive in a colder climate because they're almost always evergreen. And so they are ready to go and do photosynthesis as soon as it's warm enough for sap to flow. They don't have to worry about making leaves first and so on. So that's why you see them in colder climates. They're ready to go at a moment's notice. Some of them, the pine cone, some of them are adapted to fire too. So in some cases, the pine cone won't open and release the seeds until it's been subjected to high heat from a fire. Now, those kinds of fires would be, like the normal wildfire, would be much different than what we see in California. Because when a fire is naturally present in an environment, it's cooler. There's not a lot of material on the ground to burn, and so it stays low, and it just sort of clears up the underbrush and opens up those pine seeds. I'm not sure how I got on to California, but one of the problems in California is they have so much, you know, fountain grass. You might have seen fountain grass. That just grows everywhere in California. It's escaped cultivation, and so it's all over, and it burns when it's dry. It burns really easily, and so those wildfires will spread. Wildfire is normal in California, but because of those non-native species like fountain grass, it's much worse. Okay, so the nice thing about seeds is that they're protected. They can be away from water for a long time. Right? Obviously, they need water to germinate, but it does the reproduction part where the pollen meets the egg is not based on water, like it is similarly in mosses and the ferns. All right, let's see here. Seeds are kind of a cool thing. So the seed is well developed, even in the gymnosperms. The main difference between gymnosperms and our angiosperms is whether the seed is protected. So here we've got a seed on from a pine cone, or a pine. So on that female cone, we've got on each of the scales has an area that has the egg, which is the spore, and its surrounding nutrients. And when that gets pollinated, the pollen deposits a couple of nucleuses in there, and we get what we would recognize as a seed. Here's another version of that. So most of the seeds actually nutritive stuff for the emerging plant. This is a microscopic one. They're all going to have a protective coat to keep moisture in or out. And to emphasize how small that embryo really is, here is, oh, I've touched it now, it's not going to. There's a bean. Oop, okay. Keeps farting at me. So I love talking about this. It's always amazed me. This is a bean, but you ever pry apart the two parts of a peanut? And there's that little nubbin. When I was a kid, I never knew what that was. But that's the embryo. The embryo is tiny. A bean's pretty big. It looks like a kidney bean, right? Everything else there in the cotyledons is just nutrition for that emerging plant.
Huh. Can I ask you a question, or do you want me to wait?
No, please do.
How come sometimes the protective coat around the seed is really intense and tough, and sometimes it's not?
So it depends on how the plant, like how soon it wants to, I say want, like plants, they don't want things, but it's just easy to talk like that. So it depends on what the life cycle's like. If that seed is going to germinate right away, then it won't need as much protection. And so it's just more of a short-term thing. Other plants, in some cases, it's a matter of how the seed is distributed. And so if the seed needs to be ingested, and if that's part of its transportation plan, so to speak, you want like elephant's on my mind for some reason. You want an elephant to ingest it and walk 100 miles, then you need like a really tough seed coat. Or if you want the seed to last a long time before it germinates, they'll have thicker coats.
Thank you.
Yeah, you're welcome. So I was talking about gymnosperms, and a bean is not a gymnosperm, but I wanted to emphasize how small that embryo really is.
It's like on an egg, like a chicken egg.
Yeah. Yep.
But what a great example when we're talking with kids to use a peanut example. That's a great example.
And it'd be easy to bring in, and you can pull them apart and look at them.
Yeah, true.
those allergies.
Yeah, for sure. So some of the gymnosperms we have around here, this is ash juniper. So we call those juniper berries, but it's really a cone. That's the female cone. I was just out walking with the class yesterday. There's still some female and male cones out there, so I guess cedar fever season has not ended because they're still making pollen. Also, we've got bald cypress. That's plentiful around our river areas. And then finally, the big group, angiosperms. So this is 90% of the plant kingdom. So they're a big deal. And pretty much the oldest flowering plant evolutionary is the magnolia. Has a real basic primitive flower structure where things are kind of in a spiral rather than in a more layered fashion. Angiosperms have real common, how do I want to say this? Many angiosperms have a really close relationship with various animals, like the hummingbird for pollination, bees, moths, things like that. Two groups within the angiosperms, monocots, that's like the grasses, lilies. These aren't the only families in monocots, but they're the kind of the more well-known ones, orchids. And then the dicots, that would be like the bean seed I showed, that was a dicot. Asteraceae is the largest family in the angiosperms. It's got, well, 24,000 species in there. It's a big, Asteraceae covers a lot, the sunflower family.
Dr. A,
Yeah, sorry.
what makes the Easter lily and the foxtail, what makes them alike? The way that their seeds are on the stem?
Well, the seeds only have one cotyledon. That's how this is grouped. So, and in the case of those, you know, when a bean, for example, that's a dicot. When it sprouts, you see those first two leaf-like things that pop out. With most of the monocots, you don't actually ever see the cotyledon. It stays underground with the seed. And it's just the cotyledon is just a storage organ for nutrients. It's like a grain of corn or a grass seed. The first thing you see is the actual leaf because the cotyledon's down there. So this is, I mean, it's kind of an unusual segregation, I guess, just from looking at the plants from above, but it's all about the seed structure.
I can see the grass seed on the foxtail, but the Easter lily, the seed is the orange part?
Well, the orange part here are the anthers with the pollen. And then, so these are pollen structures here, and then in the center is the stigma for the leading to the ovary. So we don't actually see the seeds on that. I'll be honest, I've never seen a lily seed as far as I know.
Yeah. They come out, it's just like the little shoot of leaves come out.
Right. Yeah, so actually, I actually don't know if I can't remember if I cover it. I do. But so we're used to, like, some of this stuff we're used to reproducing vegetatively, like with the bulbs, like the lilies and onions and stuff. But they do produce seeds too. It's just not usually, if you want to grow lilies, you just go buy some bulbs, right?
Yeah. That's why I couldn't understand the relationship between the two.
Yeah. Maybe I'll throw some seed pictures in there next time. Some other things common about these family. On the monocots, the leaves they almost always have parallel veins. Like if you think about a grass leaf, right? The veins in the leaves are parallel. Dicots have a variety of patterns, but they have a branched veining. There is a difference in how the vascular tissue is arranged in the stem. I mean, those aren't usually things that we're looking at. A more common way to tell is the number of petals. Monocots usually have multiples of 3. So that's like, that looks like some sort of daylily there. You can see it has actually 3 petals and 3 sepals. So if we counted 3, 6, got 6 anthers. So if you compare that to the dicots, those are going to be in groups of 4 and 5. So that's another way to tell. And then usually, and the root systems are different too. Now, in biology, there's nothing like really hard and fast. There's always exceptions to something. So I'm sure out there somewhere there's a monocot with a tap root kind of system. I don't know of it, but you're going to find a lot of variety. But in generally speaking, these hold true. And then I didn't really talk much about how these all evolved, but here you can see sort of the chain. The flowering plants and the gymnosperms, now that's the cutting edge, particularly the angiosperms, the flowering plants. Those are so far the best way plants have to live their best life. But it all goes back to some green algae ancestor, ultimately, is where all these derived. I am too fidgety, really, to be holding a cup of coffee while I do this. Boop, boop, boop. All right, so the morphology. The 2 main organ systems are stems and roots. We've got a lot going on there. The roots' main job, support and gathering water and nutrients. And they'll send that up to the stem shoot system. That's the leaves, where in most plants the leaves are where photosynthesis takes place. And then of course the flowering. So here we're looking at a plant with a taproot system. And whether it's taproot or fibrous, they all are going to have root hairs, those fuzzy looking pieces on the root. And that's an outgrowth of the epidermis of the root, bless you. And it really expands the surface area and it increases how much water it can take up. Here's a sort of a side-by-side view of those. Fibrous and taproot systems. And root systems are fascinating because different plants have different strategies. If you think about every plant growing next to another plant is competing somehow for the nutrients. There's always some nutrient that's in short supply, right? Even if we're adding, you can add plenty, but there's always something that is less than the plants would like. So some plants, like growing in the wild, they'll grow really long root systems. Even these fibrous ones can be like 6 feet long, especially around here in the prairie areas. The fibrous root system is more about sending out branches to get places where there's nutrients. And so the combination of size and shape really allows them to grow, in most cases, pretty close and still get the nutrients they need. Here's a close-up of that root with a lot of root hairs on it. And you can see how those are so fine. They're really going to pull in all that moisture. Particularly important on a young root like this, right? This plant is just germinated, so it's really maximizing its potential for getting the water and the nutrients. The root hairs really are only at the tip of the root, right? So the really newest part of any root. So it's sometimes, if you dig up a tree, for example, or a bush, a tree might not be a good example, but if you don't have a big enough root ball and missing too much of the young roots, then results can be less than optimal. And it's because it just can't pull in enough water. There are other ways plants have to achieve this same thing. This is mycorrhizal fungi. This is a normal beneficial relationship between the plant's roots and this fungus. And what it does is, here you can see it where it's just completely surrounding the root. And what you don't see here really are all the little strands of the fungus that go out into the soil. So you can kind of imagine it as sort of an auxiliary root system. They don't have so many root hairs because they rely on this method, but the fungus's tendrils will extend out maybe 2 or 3 times as far as the root system alone would. And so it's really expanding its ability to pull in nutrients. The fungus will send the nutrients up to the plant, and the plant in exchange provides the carbohydrates that it makes from photosynthesis to the fungus. We have another one primarily with legumes, where they have bacteria that live in little nodules on the root, and rhizobium bacteria. And these bacteria take nitrogen gas out of the air and convert it into a form that the plants can take up. So they're basically fertilizing the plant. And they don't really get so much nutrients they get some carbohydrates from the plant, but it's more of a home, really, than anything. Let's see. So legumes, this is common in legumes, including huisache and mesquite. They all have this mutualistic relationship. Let's see here. How are we doing on time? Okay. All right, let's talk about stems. Primarily, the function of a stem is support, right? The plant needs to get its leaves up to where it can get sun, and the stem supports that mission. In some cases, you can see those bottom two, the stem actually does some photosynthesis. They also transport, so they're the transport corridor to and from the roots, support, and also some stems will store water or nutrients. And they can be really modified. For example, prickly pear, the pads are actually modified stems. All right, they're all flat, and they're designed to store water. They photosynthesize. The spines are actually the leaves. The leaves have modified. So there's a lot of modifications on prickly pear and other cactus. We've got herbaceous and woody stems, of course. There's some real similarities, like they all have nodes. That's just the distance between the buds and the leaves. The node is where the buds and the leaves are. The internode between it, that's present on both. But I mean, the main difference perceptually is really how, one's stiff and the other's tender.
So like a rose bush would be woody?
Yeah. Some other stems, we've got the stolons or the runners on like a strawberry, and some grasses do have these also. So this is an above ground stem, but horizontal. So that's a way for them to reproduce without seeds. The ginger plant there is showing, that's a rhizome. It's also a stem, but it's an underground stem. And then the potato is actually a modified, the white Irish potato. Those are modified stems. So you can see there's a lot of those storage stems are really underground. If you look at it, next time you look at a piece of ginger, you can see the scars where leaves, the leaf scars, and you can see where the buds are. So now that I've told you it's a stem, you'll look at it and you're like, oh yeah. Same with the potato, right? The eyes are buds. Okay. So some woody perennials we have around here. Bird of paradise. I call that bird of paradise because I'm from, I first learned it in Arizona, was what we called it there.
Is that the same as,
Pride of Barbados? Yeah. That's what you hear.
They sure are pretty.
Yes, Mexican bird of paradise.
And then that one on the right is a...
Huisach. So if Huisach or sweet acacia is actually a cool plant. We kind of look down on it around here because it's encroaching on the prairies. It's a native plant, and it's just doing what it's just living its best life. I don't know, that's like my phrase now. The problem is we don't let the prairies burn anymore. So all this would have been prairie at one point before it was cultivated, and fires would sweep through, and that would keep the mesquite and the huisach from really taking hold. But once that stops, and if it's not like mowed or cultivated, then they'll just grow in where they can grow. So we would consider that invasive to us, but it's not. There is a difference between this, which is a native plant, and something that's non-native and invasive, like Chinaberry. Kudzu? Yeah.
That looks really cool.
Yeah. So this is just like out of nowhere, but I read the book Shogun a long time ago, and one of the things that the guys would do is they would meditate by sitting and watching a plant grow. And I was like, that would be so easy with kudzu. You wouldn't really have to be that patient. You could just like, oh my gosh, it grew. I'm done. Nirvana. All right, buds. Buds are how the plant gets longer, right? Whether we're talking about the stems or branches or the roots, they all have buds, and that growth just kind of adds on, right? So all the growth is always at the tip. Things just get longer or taller. And I'm sure this picture's not going to surprise you, but if you take off the terminal bud, which is usually the highest one up at the end of the branch, it makes all those auxiliary buds grow more. So if you want a lot of basil leaves, you pinch them off, right? Some other growth we get in stems, and this is, I love talking about this. It's really fascinating. I always ask my students, if you ask them about growth, right? When we talk about the buds and the lengthening, I tell them if I give them this scenario, like you nail a sign to a fence or to a tree, and it's like 3 feet tall, and you come back in 5 years, how high will the sign be? And I get a variety of answers. But because the buds are where the growth happens, the lengthening growth, that sign doesn't ever change height. The tree might get taller, but not down there. Now what does happen in the stem is also cool, and that's what I'm showing up here. So herbaceous stems don't have this so much. This is more of a woody stem thing. But there is tissue around the outside of that stem that makes new parts of that stem. So it's going to make some, you can see it's going to produce xylem on one side and phloem on the other. So if I'm that tissue, and this is the center of the tree, I'm making new cells here, and so I'm always getting pushed out. And at the same time, I'm making cells out here. And so that's how that stem gets bigger. It like grows in, we only see the growth this way, but it's because of that it's pushing in two directions, but the center's not gonna move. I don't know, I hope I made sense of that.
If you have a barbed wire fence and you have a tree, and as the tree grows, the barbed wire grows into the tree.
Yeah, right, because since the barbed wire won't move, the tree is gonna envelop it, yeah. And so we can see that here, it keeps growing out and out and out. And when it gets older, we also get another set of tissue out by the bark. And so that tissue, my little interpretive dance of the xylem and phloem producing tissue, that's going on. And at the same time, in an older stem, there's tissue out there at the bark, right at the edge. The last sort of living piece of that stem is making more bark. Because as it gets bigger, it pushes out, you know, like a balloon, right? It just, the circumference expands, and so it's got to make more and more bark tissue to protect it.
So like a crepe myrtle?
Yeah, crepe myrtle would do that. So the shedding, I was talking to somebody about this, and so far as I know, no one knows quite why the bark sheds. Some bark sheds, like crepe myrtle or like cinnamon, and other bark doesn't, right? Like the oak trees, they just get more bark. And it's probably an evolutionary way to protect itself from parasites, perhaps. Like if you get rid of the bark, they're all making new bark. It's just sometimes sycamores also, right? They lose some of that outer, the dead part. This is a nice way to see all that tissue. So this cork cambium there, that's the part that makes more bark. And then this blue, or what would we call that? The sort of green turquoise color here, that is making new phloem and xylem. So the vascular system on a woody plant is always at the outside. The inside there, the inner part of the tree, that's all dead. The plant will put waste products in those cells, resins, and it gets harder and darker over time because all these waste products are in there. And it's sort of building a nice steely core for strength as it gets bigger and bigger. Since that inner part is dead, that's why you can see like perfectly healthy looking trees that have a great big hollow in them. Oak trees especially seem to, live oaks anyway, do that a lot.
Mesquite too.
Yep.
You said the middle part of that is dead?
Yes, the heartwood.
No shit.
The actual only living tissue is the cambium, then the xylem and phloem, and that cork cambium. And the rest of that, the inside bit is dead, and the outer part of the bark is also not living.
So girdling the tree to kill a tree, really you're just removing the living part.
Yeah, you just have to cut down to that cambium tissue.
Okay.
Mm-hmm.
That's why they say when you ring a tree, it dies.
Exactly, yeah. I wish my students had such thoughtful insights as you all do. It's a matter of experience, right?
So all the nutrients and water goes up through the cambium?
So the xylem and the phloem. The
phloem.
I don't have anything labeled xylem here, but it's on the inside of this.
From that.
But it goes
Yeah.
from the roots up to the outside, pretty much of the tree, you go up to the leaves, right?
Yeah. So let's see. I think I have a slide of it coming up, but this, because of this sort of architecture, have you ever heard of like layering, like air layering, or any of those reproductive techniques? That's how that works, because you cut off the. So you see the phloem as the very outside part of that. You can scrape off the phloem, and so no water's getting up. No nutrients are getting down. The xylem's still intact. That's taking water and nutrients up to the leaves. So what happens is the leaves will still function, and they're still doing photosynthesis and making carbohydrates, and they try to send them down through the phloem, but it can't because you cut it away. And then it's like, oh my gosh, we better make some roots here. And so that's what, I got a slide. If I show you on the slide, it'll be more visible than me just doing this over and over again. Kind of talked about this already. Leaves are the primary photosynthesis structures for plants. We've got different veining. The ginkgo tree is unique. It has, they call it dichotomous veining, actually. It's not really palmate. Palmate veining would be like on a, I got nothing. I need a slide. It's like a hand, yeah. I'm just trying to think of a tree, like a gum tree, but those aren't real common around here. Maple would be like palmate, yeah. Okay, let's see. Monterey oak. I don't know about that, but that's not that important. So I mentioned like the leaf modifications on the prickly pear. So the same thing goes for the barrel cactus, right? That the stem is what's doing photosynthesis there, and the spines are the leaves. Right? The leaves have evolved to be pointy and not photosynthetic. That helps it live in a really arid environment. Of course, we have juniper scales, another type of leaf. The tendrils on plants are also a modified leaf. And we don't talk about it too much, but really, flower petals, the carpels that cover the ovary, those are all modified leaves. It's just that those modifications took place so long ago, we don't want to think about it. I shouldn't say that, but it gets a little, if you go back far enough, everything's everything, and then nothing makes sense. All right, so leaves have I mentioned that waxy cuticle, so they're pretty well water and air tight. So they have openings, usually on the bottom, called stomata. And the neat thing about those, you can see them here. What we have is these two kidney-shaped cells, and they have fibers around them. So when they're full of water and they get all plump, they do their kidney bean shape. But if they lose water and they get all flaccid, they shrink up. And so that's how that opening and closing of that pore, the stoma, is controlled through the water content of those cells. The veins are a combo of xylem and phloem. All right. Got a lot of different leaves. There's an example of palmate. a nice one there. We talked about the parallel venation. This is just a small snapshot of the shapes and the venations and the margins. I mean, there's a whole poster hanging up in our lab that shows these. And I included something in the back of your packet. One of them is fruit types, and I think the other one was leaf shapes. Oh no, it was inflorescences. Okay, I'll get there in a minute, because we're going to talk about reproduction. But if you're interested in looking at the other ones, you just Google leaf shapes and you'll be inundated with more than you'd ever want to know. So let's talk about reproduction. Bulbs, we were just talking about that, so like garlic. All three of those top ones are vegetative or asexual. Oh, and the bottom one too. All of these are asexual reproduction. So the bulbs, they're genetically identical to the parent plant, right? And you stick them in the ground, they make the same plant. Holly tree there, I don't know why I didn't use a live oak, because those are notorious for those. All those little, I didn't grow up here, I'm from the north, and we don't have live oaks up there. And when I moved down here, I was like, dang, those squirrels are super busy. There's like 1,000 oak trees under that tree. And for years, I didn't think about it constantly, but then I went to school and I'm like, oh. So, you've probably seen them, all those little sprouts come up from the roots. And I'm a firm believer that a lot of the areas of our forests that have oaks in them, that many of those trees might be the same tree. They're just all suckered up. Now, whether they're the same tree or not, if they're close enough, the roots will graft together and merge, which is why oak wilt is such a problem, because it'll flow through the vascular system from one to another. Okay, hawkweed there and dandelions, they actually can produce seeds, and they look like, think about a dandelion, like that puffball of seeds with their little fuzzy bits. They can make those whether they're fertilized or not. They're fertile seeds, but whether they got pollinated is kind of irrelevant to a dandelion. So they can spread, it's still asexual even though it's from a seed. And then we see the creosote down there. This is like shoots have come up. So in that picture, in the center would have been the original plant, and then it sends up sprouts from its root system, and then the center part died, and then you get this nice ring of creosotes.
There's a lot of that at Big Bend.
Yeah?
Yeah.
Cool. And here we go. I was talking about cuttings. Let's see, what do we got here? So some stuff you can just cut, like on the left there, you just cut it at the stem, and wherever there's a node, if it's like submerged in soil or water, it'll start to grow roots. So that's a vegetative propagation. In some cases, like on the right, the leaves themselves will grow roots from where they were attached. And the begonia there is sort of famous. I use it in lab because you could cut like a circle out of the center of the leaf, and wherever the vascular system is, will start to grow roots, which is kind of amazing. Theoretically, any leaf has everything it needs to make a whole plant. So there's some leaves that you can just like cut and stick in the soil and they'll grow. It doesn't work for everything, and I'm not sure why, because like I said, in theory it should, but some other methods, I was trying to describe air layering, and that's shown down here on the bottom. So what you're doing is you're allowing the water with its nutrients to go up to the leaves, but the carbohydrates can't get down to the roots. And so it has to be covered in soil. So at that cut, at the top part of that cut, it'll make new roots. So you could do this like on a branch and let it go for a few weeks. And then you got some roots, you cut it off, stick it in the ground, you got another plant.
Rosemary, lavender, you can do that too.
Yeah. Uh-huh.
Is that the same with grafting? Like when you buy a grafted, or is that different?
That's different. So grafting is shown there on the right. So on the bottom, he is, I don't know what the plant that is, but he is cut the branch off of, let's just call it an apple. And then he cuts open so that he can sort of pry off that cambium tissue that's living and where the xylem and phloem is. And then he's whittled down these little twigs to expose their vascular systems and sticking it together. And so the twig will get nutrients, water and nutrients from that main stem, and then it'll start to grow its own leaves. So that's a way to graft. You could get like different varieties of apple, or we do it with roses a lot too. This sycamore tree, I think that's 7 trees, and what they did is they grafted them in such a way that was done deliberately. They grafted the limbs together, and they just left them attached, so that they've got this sort of basket weave done through grafting. Somebody looked that up for me. I think it's in California. Oh, six sycamores. Sycamores.
Like money tree also.
Mm-hmm.
There, you see that a lot, especially now that, and another one is bamboo.
Yeah. All right, reproduction. So I mentioned like way back, seems like ages ago, angiosperms in particular have a really close relationship with animals quite frequently. And the reason a plant, if it's a showy flower, like basically if you're driving down the road and you can see it, then it's there to attract a pollinator of some kind. So what pollinator it brings is depends on its shape and color. The flowers that you don't notice usually are wind pollinated. Like pretty soon the oaks are they're gonna bloom, but you're not really gonna know it. You know it's happening because there's pollen all over your car. And then you know it happened because then there's catkins all over your yard. But you don't really notice the catkins, which are the flowers, when it's going on. I don't know, we don't really look up much. My dog just realized the other day that there is an up. He's like, oh, there's a bird or something in that tree. All right, this is a generalized flower. I say that because it's generic, right? It's got all the parts that we would find in a flower. But not every flower has all the parts, which I'll get to in a second. So we've got an ovary with the ovule. It has a stem-like thing called the style. And up here, the stigma, that's where the pollen sticks. The stamens are the unit that has the pollen-producing compounds. Let's look at some, all right. So I mentioned that not every flower has every part. All right. So if it, I always got to keep it straight in my head. We have perfect and imperfect. Oh, I'm sorry, complete, or it can be incomplete is the other one. So a perfect flower has both male and female parts on it. Okay, and if it has one or the other, then it's considered imperfect. Now that's a smaller sort of subset A flower could be complete, in which case it has everything, like my generalized flower. Or it could be, if it's missing any part, it would be incomplete. So you could have, some flowers don't have petals. They would be incomplete. And there's a lot of shapes. Basically, they're regular or irregular. And so inflorescent types. This is that thing that just popped up. I made a version of that in the back. It's in the back of your packet. But there's a ton of different ones. It's useful in knowing what you're looking at if you're trying to identify something with like a book. But one we're really familiar with are the sunflower families, the daisies or asters. This one's actually, if it's got everything, it's got both disc flowers there in the center, which on a sunflower would be where the seeds are produced. And they're the ones that are fertile. And then the ray flowers on the outside usually aren't. So if you think about a sunflower, the petals that we see are all on the ray flowers. And all that sort of brown colored disc in the center, those are the disc flowers. And those are the ones that actually get pollinated and make seeds. Speaking of pollination, so that pollen grain lands on top of that stigma, and the top is pretty sticky. And it's also kind of, what do I want to say? Selective. So if you think about a lily, right? We like those because they're big and you can see all their parts, right? So oak pollen could land on that lily and it's not going to do anything. The lily doesn't recognize it as anything other than dust, bless you. But if the pollen matches, then it's going to do what's shown here on the left. The pollen itself, we call it germinating, just like we say for a seed. And the pollen grain starts to grow a tube down the side of that ovary up to the egg cell. This is what's shown there. So this is these two are just bigger bits. So that pollen tube comes down and it delivers there's two nuclei that come up. I mean, this is like a whole class worth of stuff going on here. But one of the nuclei fertilizes the ovule, and the other one goes up and it fertilizes some other cells that are there. So that the ovule, once it's fertilized, becomes the embryo. And the other cells that get fertilized develop into the surrounding supportive tissue, like it would become the cotyledons. So sometimes you're going to hear this double pollination or double fertilization, and that's why, because the pollen's delivering two sperm nuclei. Oh, it's right there, double fertilization. It's almost like I made these slides. Here you can see once it's pollinated, the embryo starts to develop. Kind of cool because it's funny because one of those cells right down there, it splits. So we're familiar with that, right? Any egg, you fertilize it, it starts dividing. The first split, one of them develops into this sort of anchor, and it does some very minor splitting itself to make that little blue sort of stem-like structure you see, and the rest of it develops into that. So the other one cell, then it divides into all this embryonic tissue here. And so that one little anchor point onto the outer part of that seed.
So like an avocado.
A what?
Avocado?
Oh, uh-huh.
All right, so if you use that, I don't
think I've ever seen an avocado bloom.
Well, an avocado, most of the avocado is actually the ovary wall. So actually, it's like you're reading my mind. So what happens is the ovule gets fertilized and turns into an egg, and that develops into the embryo. Or it doesn't turn into an egg. The egg's fertilized, it turns into the embryo. And that'll develop into the seed. The rest of the surrounding tissue, the walls of the ovary, they're what develop into the fruit. So for an avocado, you've got kind of three. You've got the outer part, the skin, which is protective. You got the mushy part we like to eat. And then inside is the seed, the little ping pong ball thing. Same for like a bean. What I'm showing there is a pea. So the ovary wall is the pod, and the seeds are all inside it. You can open one up next time you got one, and you can see it. Each seed is like attached, just like we saw in this other picture. Each of the little pea is attached, little attachment point to the ovary. So when we talk about fruit, we're talking about, really it's the ovary wall that we're eating. And in some cases, other parts that can become part of that. Do I have that slide? Yes, I'm gonna get to that. So here's some fruit types. Oh, here it is, right here. So consider an apple. So on an apple, the core, the part that we don't like to eat, is of course the seeds, and then there's the ovary parts. And then the outer tissue that we find so delicious is actually part of the flour that's fused together with that. There's some fruits do that. They fuse all sorts of different things together. So there's a variety of fruit types there. I gave you that handout, or one very much like it. Dry fruits there on the right, we would call them nuts. Botanically speaking, they're not all nuts. For example, a peanut is really a bean. This is going to blow your mind. So a walnut and a pecan are the same kind of fruit as a peach. Same fruit type. If you think about a pecan, so if you think about pecan's probably a better example. A green pecan has got that fleshy outer part, then that peels away and we're left with the hard part, and inside that is the seed. Just like so now think about a peach, you got that fleshy outer part. The difference is one dries up and we throw it away, and the other we enjoy eating. The main difference. So this all comes down to seed dispersal. So some of this, like some plants put a lot of effort into making a fruit because that's a great way to get that seed transported. I think in this, I forget what I was reading, someone proposed that avocados actually co-evolved with some sort of large, like maybe a mastodon or something that enjoyed eating. I think I'm mixing my stories up. Forget I said anything. But anyway, well, if you think about it, well, consider the apple. Humans are great at this. Apples, the original apple was small and green and tasted horrible. But somehow, over time, we decided we liked to eat them. And so they originated in like Central Asia. And now they're around the world and in a big variety, right? There's all kinds of apples. I mean, there's more varieties of apples than you ever see in the grocery store even, right? There's probably only like 5 there. And so it's a great success story. Evolutionarily speaking, the apple has got it made. Other methods are very good too, like dogs and other mammals are great for spreading those sticky burrs. The dandelion has a nice wind dispersal method. What else does that? Sycamores actually, they disperse like that. Cottonwood. Okay.
Because we're talking a minute, wait.
How are we doing? Yes.
I never thought of the dandelion being a fruit.
Oh yeah.
That is like, I'm like,
So-
that's a weed and a weed and a weed.
Well, so botanically, speaking, the fruit is the developed ovary containing a seed. So it doesn't matter if we like to eat it. It's still, I would call it a fruit. So like dandelion, that the seed and the little fluffy bit, paspalum is the word for it, but it's okay.
But the petals make great tea, they make great jelly, and they're very delicious.
Sure,
Yeah, great wine.
there's all kinds of fruits, botanically speaking, that you would never eat because they're poisonous or just generally nasty or insignificant. So think it's similarly with the nut, right? An actual botanical nut is, like there's a bunch of words up here that have the word nut in it, but a hazelnut is the only one on there that's actually a nut, botanically speaking.
And a chestnut, that's what it says.
And a chestnut, yeah. Oh, I have a key. Thank you.
It's easier to see on that.
Right, so a lot of times there's a difference between what we would call a fruit and what would. So what's a good example of?
Tomato. It's a fruit.
A tomato is a fruit. Yep, see it's right there.
So are cucumbers.
Cucumbers are also a fruit. Cucumbers are the same kind of fruit as a pumpkin.
Yeah.
Fruit type. It's on here, it's a peepo. I think it's on there. Maybe it's not. That's missed opportunity. Yep. But so fruit is a swelled up ovary with a seed in it. Cool. All right. So the fruit, first of all, it protects the seed, and then it's a way to get the seed where it needs to go. And it's pretty effective, right? Everything seems to enjoy eating fruits. Okay, now sort of into the life cycle. All seed has some sort of dormancy, but like we were talking about it earlier, sometimes that dormancy is really easy to break. It's like really short-term dormancy. But in all cases, the process is it has to start taking in water. And that's called imbibation. Sometimes it needs a certain level of heat or light, either no light or light. So if you think about the really tiny seeds, usually those, you don't want to bury them because if you think about it, you're a little tiny seed, inside there is an embryo and all the food it needs until it can make its own leaves. So for like a poppy seed, that's just, you sprinkle that on the ground because it needs to go right away. If it has to like claw its way through soil, it's not gonna make it. But a great big seed, like a bean, that can come up through a few inches of soil. So sometimes they need light or they won't. It's sort of like a triggering mechanism. If it's a seed that needs light to, if it needs to be at the surface, then it won't germinate at all if it doesn't have light, because that's an indication that it's buried. Sometimes they need scarification. That's like being roughed up. That could happen by being eaten and the stomach acids etch it, or it gets knocked around in the soil and just scratched. As gardeners, sometimes you'll deliberately sort of take some emery board or something to seeds. Or stratification is that damp cold. Some plants the seeds need to be subjected to a period of cold before they'll germinate. Not usually. It could mean freezing, but usually when we do it on purpose, we don't freeze them. Cool. We okay with that? Any questions? All right.
Is there a hard and fast rule on, I mean, like, the poppy seeds I can understand, don't plant them, but like for the scarification and the stratification, is there a hard and fast rule on which seeds like that?
Not that I know of. I rely on people that already know. Now, for the light, I would think, you know, if it's a really small seed, it probably doesn't go deep, but not really a rule. Yeah, you have to keep in mind, I'm not much of a gardener.
What?
I like to plant. I like to plant plants, but I have ADHD, so I tend to forget that I planted them. And so then my wife waters them, or they die. My wife will say that I don't like plants, but that's not true. I just forget about them.
Well, sir, excuse me for interrupting, but if you really get into gardening, you need to sell your little car out there and get a pickup.
Yeah. You would be surprised how much I can fit in that. They didn't call it a fit for nothing.
That's right.
Okay, so don't let all the lines on this push you around. Basically what we're looking at here is we've got two paths to make the seed. Remember I talked about the alternation of generations? Well, the blue part of this is going to be one generation, and the red part is the other. And so the top is sort of the path of the pollen. The structure that makes the pollen is made, and then it makes the pollen goes. I'm oversimplifying, but it's okay. The pollen goes and it makes its way to the female part of the plant. At the same time, down here, this middle line, we're following the development of the ovary and the ovule. All right, we get the egg in there, and then they come together, fertilize. There's that double fertilization again. And now it's back to another generation. And here in this picture, we've got the developing zygote, and the ovary walls are starting to swell. They're developing into the fruit while the zygote develops into the seed. There's our embryo. It germinates and makes a flower and starts the whole thing over again. So it's kind of cool. All plants have a similar alternation of generations. It's just in like the ferns and the mosses, it's a little bit different because they have spores, they don't have pollen and eggs. All right, how are we doing on time? I go to what, 11:40? Is that the plan? Okay, I got it. Last time I did this, I had to cut it short because I told too many stories.
11:40.
Okay, so life processes. These are the big three, okay? You can't have one without the other, but sort of the whole reason for existence, I guess, for plants is photosynthesis. I'm not sure it's the reason for existence, but they do it. So they're taking in light and water and carbon dioxide, and they're turning that into the building blocks to make cellulose and starch. There, it says sugar, right? It makes sugar, and as an afterthought, they make that ever so convenient oxygen. Now, at the same time, those plant cells, just like our cells, are doing what we call respiration, which is pretty much the opposite of that. They're taking that sugar, reacting it with oxygen, we would call that burning. And they get energy out of that, and CO2 and water are the waste products. So those kind of go back and forth, right? Now all this is going on in the leaves, and they are using, I should say, in the photosynthesis part. Sorry, I'm only used to one screen. In the photosynthesis part, they're using much more water than is made from the respiration. So as a result, combined with the water that just evaporates out of the leaves, we get this transpiration. That's just a nice big word for the movement of the water up from the soil through the roots. You could think of it, when we're using up that water up in the leaves, it's like when you're sucking on a straw. It's just changing the water, the pressure on the water. It's low pressure at the top of the plant because it's being used up, and higher pressure in the roots, in the soil, and it kind of pushes that up, or pulls it, depending on your point of view. Okay, does that make sense? Cool, all right. A pluses all around. All right. So that's not a square millimeter, obviously, but a square millimeter is pretty small, and it's got about 500,000 chloroplasts in it. Now, the chloroplast is a part of the cell. It's the part that has the green pigment in it. And there we have that middle picture right there, shows one cell, and all those little green nubbins, those are the chloroplasts. So those are those factories. So they capture that light energy. Let's look at it like that. That light energy gives them the ability to break the carbon off of that carbon dioxide. It breaks up the water molecule. And it does, there's a whole cascade of chemistry involved that if I wanted to be a chemist, I would be a chemist. But suffice it to say, it's breaking those all up, reassembling them. And in the process, it's making that glucose. And as far as photosynthesis is concerned, oxygen is a waste product. Just like for us, carbon dioxide is a waste product, right? We want to get rid of that. So, pretty much all the energy on Earth ultimately derives from the sun. So we think about, we get our energy because we either eat animals or we eat plants. So plants is obvious because we're looking at it right there. But so we eat a cow, right? I go to Bill Miller and I get some barbecue. The cow ate a plant. The plant gets its energy from the sun. So either way, whatever I eat, the energy comes from the sun. Now you remember I mentioned coal? All those big, giant fern forests were all doing photosynthesis. And so all the energy we get from coal ultimately came from the sun. Oil's the same way. Oil was some sort of living organism that would have gotten its energy through this process. Now there's like deep sea vents where some weird stuff happens, but like I said, there's always an exception. But pretty much all our energy ultimately is from sunlight. Let's see, actually, this is an interesting one. So I talked about transpiration already, but I like this because that maple tree there, that maple tree is about the size of an oak tree, right? So 200 liters of water per hour. So that'd be about approximately 50 gallons of water per hour. A liter's a little more than a quart, so, ballpark. So that's from evaporation alone. That doesn't even account for what it uses. Because at the same time, it's doing photosynthesis, so it's chugging along. Let's see. Oh, did this one pop up? Yes, perfect. Okay, so I mentioned how, right, that evaporation and the using of the water is kind of like sucking on a straw, right? At the same time, there's some other things going on because each of the water molecules kind of clings to the wall of the xylem that it's moving up. There's some very weak attractions between the molecules in the cell wall and the water molecule. So that helps it, right? So it's not just reliant on that sort of pressured action I was talking about with sucking. You can imagine trying to suck water up a straw that was like 60 feet tall. I mean, you'd like pass out or something. But because of that adhesion, it's like the capillary effect, right? You've probably seen that. If it's a small tube, the water will just move up. And it's because of this attraction shown there in the middle. Let's see. Oh, yeah. So back to those stomata. You know, sometimes that plant's going to run out of, or not run out, but if it's very dry outside, the air is very dry, it's losing the water to evaporation, it's going to trigger these stomata to close. It's going to shut them down because it's losing too much water. Now that's not a perfect solution because it has to have those open to do photosynthesis. These are, in addition to water vapor coming in and out, CO2 comes in, oxygen leaves this way. These are the only ways really in and out of the leaf for gases. So it's not a perfect solution, or it's not without impact anyway. Typically they're going to close at night, right? There's no reason to have them open, no photosynthesis going on, so they will close at night. Fun fact, cactus have they have a sort of complicated system with photosynthesis. Since in the desert, the relative humidity is higher at night, the stomata will open up at night and exchange gases. And there's part of the photosynthesis, the synthetic part of photosynthesis, captures the CO2 and stores it. And then when the day breaks, the stomata close down and that stored CO2 is released and it does the photosynthesis like we were just talking. So it like separates those two because otherwise it would lose too much water during the day. I keep mentioning phloem. Phloem is part of that vascular tissue. It's going to transport those sugars that the leaves are making in photosynthesis. So it goes all directions throughout the plant. We would call it sap. Sometimes, not all sap is sticky. Pine sap is the way it is because it's a protective measure. It has resins in it to heal up that wound. And then the latex does a similar function, like on a dandelion or a rubber tree or whatever it is in that picture. Sometimes that latex is bitter also, so it makes it less tasty.
Okay, I'm still in my head, I'm still on your last video up there. So when the stomatas are open, is that when your leaf wilts? The second line, this causes potassium to move into the guard cells, causing water to follow, which causes turgor pressure to change.
That's a great question.
It's getting greater, right?
So if the potassium moves into the cells, water is going to want to move in there and dilute it. Yeah. And so that'll make them turgid. And that a happy plant cell is a turgid plant cell, nice and plump. I liken it to like a water balloon in a box, right? The water balloon can only get as big as the box. The box is the cell wall. It's all stiff and cellulose. And there's a big vacuole, they call it, in a cell. That's where the water is. And so the shape of these guard cells is such that when they get plump, they turn into that kidney shape and they open. So this same kind of thing happens with all plant cells though. So if they lose too much water, that's when they'll wilt. They get all flaccid and floppy like old lettuce in a refrigerator, right? So it's a sign that the plant is water stressed, but a lot of times it'll come back. Like there's some plants, like house plants, where they say don't water it until it looks a little wilty. And then you give it water and it perks up and everybody's happy. If it goes too far, the structure of the plant cell gets destroyed. Basically the inner parts pull away from the cell wall and then it won't come back. So that's like permanently wilted. It's gonna die at that point.
Permanently wilted.
AKA death. Let's see. I'm so happy I didn't get this far last time. So. All right, so phloem. Phloem's carrying that glucose and the products of photosynthesis. So I don't like this. I'm not going to spend a lot of time on here because I got a better one, but this is the phloem cell here. It's basically a little tiny straw, but it has sort of a plate on the end of it, a plate with openings. So it's not completely shut. Well, hence it's named a sieve plate. You know, just like a sieve or a colander, right? Imagine that. And so that helps. It's not just this willy-nilly flow of phloem. It has to be managed. So the phloem's moving along there. There's openings. Now, this is, the word sink here is used in the term of like a dumping ground, so to speak, or a container. And so the source up there is the photosynthetic leaves. And that the products of the photosynthesis are going to move to the sink, whatever that might be. In this case, it's the root of the sugar beet. Oh, I guess I'm less happy. I still didn't make it to the end. Okay. Well, anyway, let me see. I want to show you one more thing. Photosynthesis, right? Oh, two more things. So photosynthesis, it's all about quality and quantity. So the quality there, so on the upper right, this is the spectrum that plants perform photosynthesis at. And you can see those other ones are the spectra from various light sources. Daylight has got pretty much everything. Incandescent are not super great for photosynthesis. Fluorescents are horrible. Because you can see it's like mostly green is their spike. And so the grow lights are specially manufactured to give the spectrum that the plant needs. And then one last thing, the USDA growth zones have changed, not like super recently, but this is the current one. So we're that star. We're in 9A now. We used to be 8B. So these are just moving north. The climate is warming, and it's going to continue. Hopefully we don't get to be 9B, but it might be inevitable.
How long of a change has it been? Like, wasn't it like 1995 and then more recently it changed?
I think they updated it in like 2012 or something like that.
So
do y'all, anybody know?
maybe every 15 years?
They went to 9A a couple years ago.
Yeah.
Not too far back, we got moved up to 9A.
Yeah. It was not, there's no like specific time that they updated. They just, yeah.
Does it also mean that the winters are colder?
This is, no. So here, if you, that first bullet point, I don't know what I'm pointing at over there. So 9A, the average minimum 20 to 25 degrees Fahrenheit. 8B, which we used to be, was colder.
Okay.
It was 15 to 20. So this is based on the winter. So our winters are warmer now than they used to be.
Okay, so plants.
On average.
Are based on winter, not like summer.
So,
Yeah, this one is, yeah.
you know, when I see that up there, I'm thinking average minimum temperatures.
Yeah.
But who's to say, you know, how Mother Nature is? And why they call it Mother Nature, I don't know. It could be Daddy Nature, I don't know. But it's 20, 25 degrees, but don't be surprised if we have a major Arctic front comes in and you see 9 or 10 degrees for 3 or 4 days. And in the future, it may skew that a little bit, but it doesn't happen overnight. They have to, it's all based upon 5 or 10 year histories.
Yeah.
As that.
And then also, I mean, it was like 20 a week ago, and now it's 80.
God bless.
So the average is 50. But, okay, I'll leave it at that. That's pretty much everything. You feel free to email me if you ever have questions. I'm happy to answer them. Yeah.
I was gonna say the most recent map was about 23.
23? Oh, okay. Great, thank you. So 2 years?
Any other questions?
What's your email address?
Oh, let me put it up there. Let's see.
It's really easy.
It is easy. I'll put it on this slide right here. Let's see. We'll do that. Yeah. Oh, here, use this one actually.
And you can always go to TLU, Google TLU, go to all the instructors, and he's listed there also.
That's my work one. I get so much junk at my Gmail address, I hardly ever read it. So if you really want to get a hold of me, that's the way to do it. All right, cool.
All right, let's give them a hand.
Thanks.